Hello and welcome to our lesson on what we call effective rates. So in order to explain the concept here, I'm going to take you back a little bit. So remember we started by calculating simple interest, and simple interest is like it says, it's pretty simple to calculate because all we're doing is calculating once for a period of time. One time we're going to calculate some fee that's going to be charged on a loan or some earning on an investment if the interest is what we call simple. If it's compound interest, then your interest is calculated, remember, n times over a period. So it could be monthly, daily, weekly, whatever that number of times can change. And or each time the interest is calculated, you're calculating interest on the principal amount and the new interest that gets added in. So it's a little more challenging to determine the resulting fee or on your loan or earning on your investment at the end of it all. Okay, so we do have a formula that calculates the final amount and we can figure out the interest. It's just a little more complicated, right? So what an effective rate does is it shows the real rate of return on your loan, or on your fee on your loan or on your investment when you have compound interest. So if, for example, you have 5% compounded interest monthly, at the end of a year, what has actually happened? What's the actual overall percent gained on your investment or the percent charged on your loan? So we can sometimes call an effective rate a real rate of return. And actually calculating an effective rate is going to be pretty easy, but the concept is a little tricky. So let me try to explain this a little bit further. So let's say we're going to consider we have a $100 investment at 5% for 1 year. Okay, so $100, 5% per year. Let's say that this was an investment into a simple interest account. If it was a simple interest account, then the interest is going to be equal to principal times rate times time. So $100 principal times a 5% rate, which is 0.05 times the time of 1 year, means our interest is going to be, if you could do this without a calculator, awesome. I just want to make sure you're all with me here. So that's going to be $5. Okay, so $5 in interest. I know it doesn't seem like much, but I picked these simple numbers so we could see exactly what's happening. So what's happening here is we go from $100 original principal. So we go from $100 to we end up with the $5 in interest added to our principal amount of 100. So we go to $105. So if you're going from $100 to $105, remember our percent change formula says to take that newer amount, subtract that previous amount, and then divide by that previous amount. And you see there is a 5% gain after we multiply by 100 and change that to a percent, a 5% gain. And that's why I used 100 here, because it's really easy to see. From 100 to 105 is a 5% gain. So if you're going from 100 to 105, that's a 5% gain for the year. Okay, and again, pretty easy to see. It's $100. It's only a year. A 5% simple interest is a 5% gain. Okay, so again, simple. With compound interest, it's a little more tricky. So let's say we're looking at interest that's compounded monthly for this particular scenario. So our compound interest formula, remember, a little more complicated here, but here it is. Compound interest formula says we're going to take that $100 principal, multiply by 1 plus our rate of 5 over n. Monthly would be 12, and then we're going to raise that to the n times t power, so 12 times 1 year. And we end up with, let's see, calculator, 100 times 1 plus 0.05 over 12 raised to the 12 times 1 power is 105, and then we're going to round that to 12 cents. So 105.12. Okay, so that means in this case we're going from our $100 investment to we end up with $105.12. Well, what percent gain is that? Again, you can see it, but let me just reinforce. We're going from 105, or we ended at 105.12, started at 100, And if we divide by 100 and then multiply, we see that is a 5.12% gain. That's a 5.12% gain for the year. So even though it is a 5% interest rate, because the interest is compounded monthly, at the end of a year, you've actually gained 5.12%. That 5.12%, that real actual gain, is the effective rate. Okay, so effectively, the 5% compounded monthly amounted to a 5.12% gain. So therefore, we say that the real rate, or the effective rate, is 5.12%. So basically what it does is it figures out the simple interest rate that would give you the same final amount as your compound rate over the course for a year. And it doesn't matter what principal amount you start with, if you're only looking at a year, these percentages will hold. Okay? So there are technically two names for what I'm calling an effective rate. That's like a generic name. It's also referred to as an annual percentage yield. So annual percentage yield, which could be abbreviated APY, or sometimes we call it the effective annual yield. And notice in both of those the word annual, which means yearly. So what we're doing is comparing what is the actual real overall gain over the course of a year when you're compounding interest. Okay, so we have a formula for APY, effective annual yield, effective rate, all sort of interchangeable words. Looks a lot like our compound interest formula, which makes sense because it's determining the effects of compound interest. But notice there's no time involved. Well, there is, but the time is going to be annual. It's going to be 1 year, so we don't have to put that into the formula. And again, it doesn't matter what our starting amount is, the rates are going to hold, and so the principal has been removed from the formula. Okay, so we only really need two things to be able to calculate an effective rate. We need to know the compounding rate. So are you compounding 5% interest, 7% interest? What is the rate? So we need to know R. And again, that's going to be given to us as a percent, but it will be plugged in as a decimal. And we need to know how many times the interest is compounding per year. So we still need to know N. Is it monthly, weekly, quarterly, annually, semi-annually, daily? What is it? Okay, and remember, our formula is going to be calculating a rate. It's an effective rate, and so it's going to spit out a decimal value, but in order to interpret it, we're going to want to convert that to a percent. So it's going to be calculating a rate. It's going to spit out a decimal, but we'll need to convert to a percent to understand it, and converting your rate, your decimal, to a percent just means to multiply by 100. Okay, multiply by 100 and you'll figure out what that is. So let's look at some examples. Again, the calculation is pretty simple. It's just understanding what you've actually calculated, which is a little trickier. So I have an example, and then I'll try to put in some meaning for you so that we can really fully get a grasp on this. Okay, so number one, it says to determine the effective annual yield of an investment with 6% interest compounded quarterly. So our APY formula says to take 1 plus R, which is 6%. 6% is going to be 0.06 as a decimal, and that goes over N. If it's quarterly, that means N is going to be 4. And let me make better notes for you here. So 6% is 6 out of 100, which is 0.06, and then quarterly means N is going to be 4. So our APY, again, is going to be 1 plus 0.06 over 4, and then we're going to raise it to the 4th power, and then at the end of that formula there's an additional minus 1. Don't worry so much about that minus 1. It is part of the formula to make sure that we're not worrying about any principal amount. Okay, so now it's just going to plug this into our calculator. So we've got 1 plus 0.06 over 4, and then we're going to raise that to the 4th power and subtract 1, because see, if we don't subtract 1, we're looking at over 100%, which obviously can't be possible. So let's take that one out. And now we're at 0.06. 0.06, let's just say 0.0613. No, let's, after the 3 is a 6, so let's go 4. Oops. 0.0614. And again, if we multiply this by 100, so let's multiply by 100, we can see that's 6.14%. So that is 6.14%. Okay, so what does that mean? That means at the end of 1 year, no matter what your investment amount is, at the end of 1 year, if you have 6% interest compounding quarterly, you're actually going to have a 6.14% gain in that investment. So it would be like a 6.14 simple interest rate. All right, so the meaning is after a year of 6% interest compounding quarterly, there's actually a 6.14% overall gain. There's actually a 6.14% gain. Okay, so after a year, you've effectively earned 6.14% because the 6% was compounded quarterly. All right, so 6% compounded quarterly would give you the same final results as 6.14% simple interest over the course of 1 year. Okay? All right, let's try that again. So the wording is a little different on the next one, but it is the same process. So the first one says determine the effective annual yield. This one says to determine the annual percentage yield. That is the same thing. So here it's determine the annual percentage yield for an investment earning 8% interest compounded daily. So 8% is 8 out of 100. That's 0.08. And compounded daily means n is 365. So our APY is going to equal 1 plus 0.08 over 365 raised to the 365th power minus 1. And so we go to our calculator. We've got 1 plus, again, 0.08 over 365 raised to the 365th. And then we're going to take 1 away. And the formula spits out for us 0.0833. If we take that and multiply by 100, we can see that's 8.33%. So that is let's change colors here. That is 8.33%. Okay, so again, if we had 8% interest compounding daily, at the end of the year, the investment will actually have gained 8.33%. So the real, and I'm just going to try to change up the wording so that you can, again, try to fully grasp. The real gain on 8% compounded daily for a year is 8.33%. Okay, so again, just to try to vary up the wording. All right, so we look at the next one. Again, a little bit of a different wording and a little more context, but it says a credit card company is charging customers 13% interest compounded monthly on unpaid balances. What is the real rate that they are charging annually? So they're telling you they're charging you 13%, but because it's compounded monthly, they're really going to be charging you more than that. Again, the wording is different, but it's asking for what is the real rate. The real rate is the effective rate, and again, it says annually here, so we're looking at 1 year, so that is what is the effective annual yield or rate. All these words mean the same thing, okay? So 13%, that's 13 out of 100, or 0.13, and it's compounded monthly, which tells us that n is going to be 12. So our APY is going to be 1 plus, we're going to go with 0.13 over 12 this time, raised to the 12th power minus 1. So where do we end up with, or what do we end up with, or where do we end up at? Sorry guys, no English major here. Okay, raise that to the 12th, and then let's take 1 away. And so the formula spits out for us 0.138, and that is, again, if you want to multiply by 100 because you have a hard time looking at it, totally fine. That is 13.8%. So customers are thinking they're being charged 13%, but because the interest is compounded monthly, at the end of the year, those unpaid balances are actually being or accruing 13.8% interest. So the actual rate being charged annually is 13.8%. It's bogus, right? Okay. All right, last one. Again, the calculation, fairly simple, just so we understand the different scenarios in which this sort of happens here. It says, while the investments at a firm earn 1.9% interest compounded monthly, the firm advertises to clients a 2% return. So their investments earn 1.98% interest compounded monthly, but they're telling clients that they're getting a 2% return. Are they lying? Is this false advertisement? So this firm is saying that you're getting 1.98% compounded monthly, but effectively it results in a 2% return. So we have to calculate the effective rate for 1.98% compounded monthly and see if that is in fact a 2% return. So we actually have to determine if they're telling the truth. So we are looking at 1.9% compounded monthly. Let's see, 1.98% is 198 over 1.98 over 100, which is 0.0198. And then monthly, again, tells us that n is going to be 12. So our APY is going to be 1 plus 0.0198 over 12, raised to the 12th power, minus 1. What do we get? Let's see. 1 plus 0.0198 divided by 12, raised to the 12th. Take that 1 away, and we're looking at 0.01998, 0.1998. I kept a little more on the decimal there because it's like, where do we round this guy? So 1.998%, effectively 1.998%. I would say, yeah, that's pretty close to 2%. Okay, not quite getting there to 2, so I don't think it's false advertisement. I think it's about 2%. So I would say no. Okay, the effective rate is almost 2%. It's about 2%. Let's say just about 2%. Okay, so the effective rate for a 1.98% interest compounded monthly is 1.998%, so it's about 2%. I think that's pretty fair for what they're saying. I don't know if anyone's going to understand what that means, but you will, hopefully, okay? So I think you have enough to get you going here. Again, the actual calculations you're going to have to make in your assignment will be pretty straightforward, so hopefully it's not too bad, but as always, if you have questions, need some extra help, then just reach out. All right, guys, take care.